Good afternoon, everyone. Hope you're having a fantastic day. Uh, I want to start off here with saying that what we're going to do on this unit, on this lesson, solids of revolution, using the disk method. It's a simple task, but it's kind of a complex thought, or it's a kind of a complex idea. So before we get into the solids revolution deal, I do want to point out on the back page here, I've given you a couple of example references. Example number one references example number one, and it's a three-dimensional drawing to kind of help you out, help you visualize what's happening here. But let's just kind of get into the long of it, I guess. There's three examples we're going to do today. Solids of revolution. It says find the volume of a solid. So I'm going to be finding a volume of a three-dimensional object here of revolution obtained by revolving the plane region R bounded by y equals the square root of x, the x-axis, and the line y equals x equals 4 about the x-axis. What I'm going to be doing here is revolving a graph around the x-axis in 3 dimensions. Okay, so first let's go ahead and draw this thing out here. Got my x-axis.
I need a night custodian.
We need a night custodian. Here's, oh my gosh. Here's the square root of x, right? Here's the square root of x. The x-axis is here, and the line x equals 4. So let's do this. Here's the line x equals 4. And what I've got here, and I'm going to shade this in kind of lightly, is this region. The x-axis, square root of x, and 4. And what I'm going to do here, and let me kind of zoom in because this is a little far out. You've got the question in front of you. I want you to kind of see what I'm going to do here. What I'm going to do is revolve this shape around the x-axis. So you can kind of imagine this is almost like a cutout, right? And I'm revolving it around the x-axis. And to give you an idea of what that's going to look like, if you flip over to 2 pages from there, here is the line y equals the square root of x. And what the disk method does is it lets us find the area of this little bar right here and then revolve it around the x-axis to form this guy. So I'm kind of taking it and swirling it around. I'm going to try and get one before class, but if you can imagine a bell, or not a bell, like one of those party favors you unfold and it kind of accordions itself around and you end up with a ball, but it's all made of paper. I'll go find one before class. But anyway, if you were to take this and revolve it around the x-axis, so you kind of spin the x-axis here, this thing ends up making almost like a bowl shape. You can kind of see it right here. If we take just this one flat sliver, this plane, and we revolve it around the x-axis, we end up with this guy. And what we're trying to do is figure out what's the volume of this three-dimensional object. And here's how we're going to do it. So back to example 1 here. Just a couple of things. This line right here, this is x equals 4. Right? This line is y equals the square root of x. Let's go ahead and get these labeled. And what we have to come up with is what our radius is going to end up being for this revolution. Now again, what I'm looking for is the distance from here to here, this radius. I need to figure out how tall is this little bar going to be here. Alright, so here's how I'm going to do that. I'm going to say that my radius goes from 0 to this graph, right? My radius has to be the square root of x. And it's going to change, obviously. If it's over here, it'll be this small. If it's over here, it'll be this big. Right? Now, how we came up with this right here, how we got this, and how you'll do this from now on, your radius is the top equation minus the bottom equation. The top one is the square root of x, the bottom one is 0. So for this one, the square root of x minus 0 is the square root of x. All right, now think about this in terms of a disk, because what this is forming, and I'm going to keep flipping back here, what this is going to end up forming is a disk inside, right? You've got this distance here, this is delta x from here to here. And if you revolve it around, you're going to end up forming a disk inside of this thing, right? So what I'm trying to figure out, it says find the volume of the solid of revolution using this area revolved around the x-axis. So here's how I'm going to do that, all right? And then I'll go over and I'll give you some formulas to use, but I just want this to make sense for a second. First, what I'm looking at is I want that disk, I want that volume of that disk, and then I'll figure out how wide that disk is going to be. I'll change my delta x. But just that disk itself is pi r squared times delta x. And here's what I want to get at. Let me zoom in real quick right here. Man, that's kind of bright. I think it's the sun. Oh yeah, there we go. Delta x, what we're doing here, if we create a little bar inside of this, and let's say I want to make a disk out of that, I revolve it around the x-axis. This delta x right here, the width of that bar, is going to be the height of a cylinder, right? Right here. The width of that bar is the height of this cylinder. So let's say I want to find the volume of this cylinder. And this is where a little bit of calculus can come into play. The volume of a cylinder is pi r squared h. But our h here is just delta x. Oh my gosh.
Walter Jones, please come to the front of the building. Walter Jones, your ride is here at the front of the building.
Walter, for goodness sake, Walter. Now, how we take that into a calculus step, remember that we said my radius is going to be the square root of x. So I'm going to take this and I'm going to integrate from 0 to 4. And this is going to be pi times the square root of x squared. And delta x, I'm going to integrate with respect to x. This is the calculus step. All right? This is taking it to that calculus mindset. And I'll show you a little bit more about how to do it, or how to find the things here in just a second. All right, so let's power through this real quick. Pi is a number, right? It's a constant, 3.14159, blah, 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 blah. So we can pull that out and just call it pi, the integral from 0 to 4. Square root of x squared is x dx, which is just pi x squared over 2 times x squared over 2 evaluated from 0 to 4, which is 8, 4 squared is 16 over 2 is 8 minus 0. So what you end up with is 8 pi, or approximately 25.133. All right. Now again, there is a format and a formula to follow for this, and I'm going to give that to you now. So this is going to require,
Attention in the building.
oh my
Julia
Lord,
Videlis, please come to the front of the office. Julia Videlis, please come
all
to the
these
front of the office.
tiny little children. What I would like you to do is go to the second page below example number 3. I'm going to give you some formulas real quick, and I want you to have them now so you can reference them later. Go a little bit more than halfway down the page here, and I want you to write this down. All right? To find volume by the disk method, here's your format, okay? The volume of a disk is going to be pi, always pi, times the integral from x1 to x2 of r squared dx. And this comes with a few steps here as well. It comes with a few steps. Step number 1 is to find delta x or delta y. Are you integrating with respect to x, or are you integrating with respect to y? This could also be volume of a disk with respect to y is pi, the integral of y1 to y2 of r squared with respect to y. So your first step is to figure out, is it with respect to y or is it with respect to x? That's integrating top to bottom or right to left. Remember, we kind of talked about that the other day. Your second step is to find r. And your last step is to figure out your bounds, your limit of integration. All right? Excuse me. So let's go through and figure out some of these real quick. I'm going to keep that formula handy. So let's go to example 2. It says, find the volume of a solid generated by revolving the curve y equals x cubed. So this is with respect to x. That's step 1. So I know I'm going to have delta x here. The y-axis and y equals, well, maybe not. Let me nix that. Never mind. I should have read a little bit more. Y equals x cubed, the y-axis, and the line y equals 3. About the y-axis. Should have kept reading. We're revolving about the y-axis. That is delta y. My fault. All right. Let's come up with a picture. Y-axis and y equals 3. So here's y equals 1, 2, 3. Y equals 3. And then you've got the line x cubed, which is going to come up like this, go like this, yada yada. And then the line y-axis, so around the y-axis, I'm going to put which way I'm revolving it, right? So around y. So you can kind of see here, this is the area I'm working with. All right? And I'm going to be turning it around the y-axis. So it's going to end up looking like an upright bowl kind of shape. Okay, so let's figure out what this is going to be here. The equation that they gave me is y equals x cubed, but I'm with respect to y, so I've got to solve that for y real quick. So let's cube root it. X equals the cubed root of y, or y to the 1/3 power, however you want to say it. Since we're going to be integrating, let's go ahead and change it to the 1/3 power. Looking ahead, that'll make it a little bit easier. Now, since you're revolving around here, your disk is going to emanate from the y-axis. So here's my disk. Always draw your disk. So there's my disk. This is delta y right here. All right. So the radius of that disk then is going to be y to the 1/3 power. Y to the 1/3 power. So on my steps there, number 1, it's delta y. Number 2, my radius is y to the 1/3 power. Now I need to find my bounds. All right, so let's set this thing up. We've got the volume of a disk, pi r squared delta y. This is minus the calculus. You know what? You don't need to see that. Let's do calculus. Volume equals pi integral. Now where are we integrating from and to? Because this has to be y1 to y2. So our lowest y value here is going to be 0. Our highest y value is going to be 3. I don't know why I keep wanting to go back and do it the algebra way. That doesn't help anyone. Of y to the 1/3 squared, because it's radius squared, dy. So that's going to be pi This is y to the 2/3. Integral from 0 to 3, y to the 2/3 dy. I don't know why. I keep wanting to go back and do it the algebra way. I have no idea why. It doesn't help anyone. But anyway, moving on. Volume is pi. Integrate this, we get y to the 5/3 over 5/3. 3y to the 5/3 over 5 is what that'll simplify to. From 0 to 3. So your volume, you throw a 3 in there. Goodness. 3 to the 5th, the cube root of that. You could do an approximation. If it's the AP exam, here's what I would write down. 3 pi times 3 to the 5/3 over 5. And then you can find the decimal equivalent of that, because when you plug in 0, it's all going to go away for the minus f of b. The decimal equivalent of that is like 11.763. All right. But if you're on a free response, this is the guy you go with right here. Just plug in your 3 and have at it. I'd leave it just like that, especially if it's non-calculator. Ooh. If it's non-calculator, I'm definitely not going anywhere past that right there. All right. Oh, I didn't even show you. I have examples. Look at it. It's pretty. This is example 2. It's in your packet, a couple pages over. This is example 2. This is the x cubed, y-axis. It's even shaded there for you. This is the 3-dimensional view of it. I mean, you can probably figure it out by there, but this one it's going to help a lot on. Example number 3. Seriously, you've got to be kidding me.
Please come to the front of the building. Courtney East, please come to the front of the building.
Okay. All right. Number 3. Find the volume of a solid formed by revolving the region bounded by a graph. Fantastic. G of x equals 1 and about the line y equals 1. Now this one might be a little bit more interesting now. Let's graph this and see what we can come up with. So I've got 2 minus x squared, which is negative x squared plus 2. So it's up 2, and it's opening down like this, like a parabola. And the line g of x equals 1, so here's the other line I'm doing. Okay. Bounded by these two graphs. So here's my region. Right? And I am rotating that around the line y equals 1. Well, that's actually right here. So this one's kind of rotating up there in space. Okay, so remember your radius is going to be the top minus the bottom. So come up with your radius here. And we've got 2 minus x squared minus 1, which is just 1 minus x squared. And then, oh, I'm sorry, step 1, delta x or delta y. Well, since I have a top and a bottom, this one's going to be delta x. Since I have a top and a bottom, this one is going to be a delta xer. So again, volume is going to be, now this one is going to be a little bit different. Before I give you this, let's look back over at this example here. All right, so here is the parabola that we're doing, and it's kind of weird, but this is basically what it ends up being. It's not a sphere like this, but this is just so you could see it. It's revolved around the line y equals 1, and it's gonna be much more ovally than this. I just couldn't find a shape that worked well. So it's going to end up creating like a spherical solid almost. So you're revolving it around here, Now it's 1 up, so it's going to come 1 down. You can kind of see where this is going to be. I'm sorry. You can kind of see where this is going to end up at. Revolved around. So your volume is pi. And where do these things meet? Down 1 over 1, this is going to meet at 1 comma 1. Down 1 over 1, negative 1 comma 1. Again, if you have your calculator, you can just do trace and intersections there. Volume is pi, the integral from negative 1 to 1. Find the area of this region in here of 1 minus x squared dx. Now, if you haven't noticed already, I want to point something out to you. Focus for a second here. Really, all you're doing is finding the integral of this area and multiplying it by pi. That's really all you're doing. Finding the area of that shaded region and multiplying it by pi. That's really all it is. This one ends up being 3.351, and of course we don't have units for these. I can go back on all these and put units squared if I wanted to. But really, all I'm doing is taking the area of this region and multiplying by pi. Have a good one.